we already know statistics is concerned with describing, interpretation, and analysis of data. And we already know statistics can be divided into two main branches. First branch of statistics is descriptive statistics, and second branch is inferential statistics. In the descriptive statistics, what we are doing, we are trying to explain about the data set. What is the mean of data set? What is the median? What is the variability of data set? Likewise. In the inferential statistics, what we are doing, usually we are collecting data from a sample. Because of limitation of time and money, we cannot collect data from entire population related to the problem. Therefore, we are collecting data from sample. We discuss different sampling methods. Using appropriate sampling method, we can collect data. Now we have collected data and we can describe the properties of data using descriptive measures. After describing data, next step is to predict properties or characteristic of the population from this sample statistics. So that process we called as the inferential statistics. So descriptive statistics deal with describing, summarizing, and organizing data for easy interpretation and understanding. We use two methods to describe data set. First method is numerical method. In there, we are using numbers to describe main features in our data set. Second method is graphical method. Here, we are describing our data set using visual aids. In today's lesson, we will learn numerical method of describing our dataset. In the numerical method, we are giving representative values for our dataset, or usually we called as for the distribution of the data. Here, we are using mainly arithmetic procedures to summarize our dataset. For example, arithmetic mean. Numerical method, we can describe dataset on three aspects. That is, first aspect is measure of center. We called as measure of central tendency. Second aspect is measure of spread. We called as the measure of dispersion. Other aspect is measure of relative standing. Here we are describing relative position of data points with respect to all other data points in the data set. In the central tendency, we are describing what is the center, what will be the common value in the data set. In the spread, we will describe how each data point deviate from each other. What is the deviation of the data set? So now we will discuss first measures of central tendency. Under the measure of central tendency, we have several measures. First one is mean, or commonly called as average. Then median. Third one is mode. Fourth one is mid-range. We have several versions of mean. Sometimes appropriate measure of mean will depending on the type of data. One type of mean will not appropriate to some type of data. So first version of mean is arithmetic mean. Second version we called as the geometric mean, and third version we called as the harmonic mean. In the arithmetic mean, what we are doing, we are adding each observation. We are adding first observation x1 plus x2 up to xn and divided by number of observation. So this is the arithmetic mean. Symbolically, we can represent this as this addition. This addition we called as addition or summation. It is represented in statistic using sigma, capital sigma. This means we have to add everything in front of that. So, in general, these any of observation, this first observation is this one, second observation is this one. Likewise, this is the nth observation in our data set. In general, any of these observation I can represent as, that means ith observation. I may be 1 in first case, I is 2 in second case, likewise I is n in last case. So this meaning sigma xi meaning we have to add everything here. What are those things? Xi's. Xi representing values I from 1 to, so I varies from 1 to n, and we have to add everything those i's. So this is the expanded notation equivalent to this one, and this is the summation. Then we have to divide everything, by number of observation. We denoted as n. So formula to represent arithmetic mean is equal to sigma xi, where I equal to 1 to n, divide by n, number of observation. Arithmetic mean we represent as x bar. This sign we called as bar appear on top of any letter that tell average of that variable. Here our variable is x. This bar represent the average. So we have to find the arithmetic mean of that variable in order to find this quantity x. One disadvantage of this arithmetic mean is this is affected by extreme observation. That means in a data set, there may be unusually large or unusually small observation. So assume in your class, I have your marks. All are above, say 60, and one student is there who has obtained 2 marks. So that is an unusual observation for that data set, and we call that 2 is extreme observation or outlier. One disadvantage of arithmetic mean is it is affected by these outliers. Even though most of student has scored more than 60, due to this outline observation. Number 2, the mean is getting reduced. It will be less than 60 because of influence from this uh, least observation, lower observation. That is one is disadvantage of arithmetic mean. So arithmetic mean of this data set, as I explained, can be calculated by using this formula, that is summation I, where I equal to 1 to n. So this I represent first observation in first case, that is 116. Second observation when I equal to 2, that is 89. Third observation when I equal to 3, that is 72. Fourth observation when I equal to 4, that is 55. Fifth observation when I equal to 5, that is 91. And sixth observation when I equal to 6, that is 48. That mean this part we called as numerator of division. This is numerator, this is denominator. This is we called as numerator. So in numerator we have sigma I equal to 1 to n xi. When we expand this one, it can be written as x1 plus x2 plus x3 plus x4 plus x5 plus x6. When we replace this i's by actual observation, it can be written as 116 plus 89 plus and up to 48. Then here denominator is n, that is number of observation. Here I have 6 observation, so I have to divide this sum by 6. So arithmetic mean of this 6 observation is 78.5. Second version of average is geometric mean. One disadvantage of arithmetic inverse effect of extreme observation, extremely large or extremely small observation. Geometric mean is not affected by extreme observation. This mean is used to calculate the average of rates, variable rates. For example, growth rate. Assume in a study, we have inoculated one culture media with bacteria. Assume virus, COVID-19 virus, we inoculated 5 in assume cells initially, and assume each 2 minutes this is double. Then after 2 minutes this amount will be double, mean then one observation will result 2 observation. So here it will be 10. Then after another 2 minutes it will be 20. Likewise, this number of cells getting increase with the time. Here lower value will be 5 and upper value will be much greater after assume 1 hour. So if we calculated arithmetic mean here, it will be somewhere closer to this larger value, because high influence of this large observation. But objective of measure of central tendency is to represent the center, here center. Due to these large values, center is moved to that extreme observation to upper side. But if we use this geometric mean, it will reduce the influence of these extreme values. So, in order to represent mean value of rate variable like exchange rate or growth rate, we use geometric mean. The formula used to calculate geometric mean is, you know, this symbol, that is, we are using it to represent root. Here we need to get the root of this one, that is product of every observation. Like we denoted sigma to represent sum, we use phi to represent product. So symbolically, I can write this equation as phi xi, where I equal to 1 to n. That means I need to multiply each and every observation to get this part. And in order to get the geometric mean, I need to get nth root of this part, this product. So geometric mean we represent using G. So geometric mean equal to product of each is nth root of product of every observation in the data set. So I have here 5 values. If you calculated arithmetic mean of this data set, it will be around here. But you can see, if we properly represent the center of data set, center will be here. So it should be 9. But you can calculate arithmetic mean is much bigger than 9. But if we get the geometric mean, you can see value is 9. Value is 9. This exactly represent the center of the data set. So you can see here data in a exponential growth. 1, 3, 9, 27, 80. It is increasing rate. So to represent this kind of data set, we use geometric mean. Second measure of central tendency is median. Median is the middle value of a data set when the data are listed in order. We can list data in ascending or descending. Median is the middle value of a data set when data are listed or sorted in order, ascending or descending. So median divides the data set into equal part, 2 equal part. If we have here data set, my data set, median divide data set into 2 equal part. This is the median, where half of the data will be less than the median and half of the data will be greater than median. Like in the arithmetic mean, median is not affected by outliers or extreme observation. we can find the location of median of a data set using this formula. That is n plus 1 divided by 2, where n is the number of observations. If there are 10 observations in our data set, n will be 10, n will be 10, then n 10 plus 1 is 11, divided by 2 is 5.5. So, median of this data set will be at 5.5th location of ordered data set, of the ordered data set. Median is the middle of the data set. Can be find the location of median by using this formula, that is n plus 1 divided by 2. So in this data set, we have given the total land area in pilot district, and we need to find the median land area of this pilot district. So first we have to rank this data set. Here, when we rank it in descending order, first rank goes to 15,575 likewise, and since here we have 5 observation, n will be 5, then location of median will be 5 plus 1 and divide by 2. That is, our median will be at third place of ordered data set. So this is the first place, this is the second place, this is the third place. So median value of this variable land extent will be 11,732. Sometime when we calculate the location of median, it will not exact directed to exact value. Here, for example, we have 6 data points, and then 6 plus 1 divided by 2 is 3.5. So our median is at in between third observation and fourth observation. So in order to find the median, we have to find the place in between these two observations. In order to do that, we can add these two observations and divide by 2, since it is at halfway from third observation and halfway from fourth observation. Add these two and divide by 2. So the value will be 11,878.5. Then next measure is mode. The mode is the value that occur most often in the data set, most common value. In this data set, you can see 45 occurs 4 times. So that is the most commonly occurred value in this data set. Therefore, 45 is the mode of this data set. Sometime for a data set, there will not be a mode. Sometime there may be 2 or 3 modes. Not like in mean or median, mode can have 2 or more values or no mode. Here, I have given a graph of several data sets. In first data set, I have a mode. Here assume value is 20. This is 10, 11, 12, 13, likewise 20. and this is the frequency. This height represents the frequency. So highly occurred number is 20. So only mode is 20. If our data has that kind of distribution, we call that as the unimodal data set. And we have one mode for that data set. If our data set has two peak, we call those as bimodal. You may familiar with the rainfall pattern of Sri Lanka. It is a bimodal rainfall pattern. We have two peaks in Yellow season and Maha season. Similarly, our data set may have several modes. Next measure of central tendency is mid-range. This is the middle value or average value of highest and lowest observation. So in this data set, we have 87 as highest value and 13 as least value. So average of this one is 50. So mid-range is 50. So that is all about the measure of central tendency. Then we will go to measure of dispersion. Here we measure the spread of data set, spread of data set. How data is spread in our data set. We have several measures for measuring the dispersion also. First measure we called as the range. Second measure we called as the mean absolute deviation. Third measure we called as the variance. Fourth one, standard deviation. Fifth one, interquartile range. Sixth one, quartile deviation. I think you are familiar with the range. That is the difference between largest and smallest observation in our data set. We have this five data point in our data set, 8, 9, 8, 10, 11. So here largest value is 11, smallest value is 8. So difference is 3. So range is 3 for this data set. It is easy to calculate, but to this measure, other observation will not contribute. Only extreme values, that is lowest and highest value, will determine the range, not majority of the observation in the data set. So it does not have good statistical properties, but this is used frequently when reporting the result. So it is simple to understand and easy to calculate. We commonly use range in quality control area, weather forecasting, share price, and disadvantage of range is, as I explained, it is affected by outliers or extreme observation. It is the difference between most, least, and highest value. Another disadvantage is sometimes you may get secondary data. As we learn source of data, we have primary data and secondary data. In the secondary data, sometimes this data may have summarized in halfway. You will not get raw data. You will get the summarized data as frequency table. and some classes in the frequency table may be defined as less than some value, assume less than 10, and greater than another class greater than 200. So if we have this kind of data, we cannot find the exact range because we don't know the exact value. Here less than 10 it indicates. Here greater than 200 it indicates, because this data we taken from some other source and they have half process. We don't have original data in order to find the range. Second measure of dispersion is mean absolute deviation. We learned that one disadvantage of range is it is not get contribution from each and every observation of the data set. To overcome that problem, the statistician has defined another measure of dispersion called as mean absolute deviation. Here, mean absolute deviation is calculated by deducting mean of the data set from each and every observation. So assume we have our values in the data set x1, x2, x3, likewise xn. We know we denote the average as x bar. So first we have to deduct average or x bar from each and every observation. We call this as the deviation. This as the deviation. So this is the deviation of each and every observation from their mean. And in order to give a summary of this deviation, if we add this deviation, that is summation xi minus x bar, if we add all of these deviation together for any data set, this will be 0. This will be 0. So we cannot give summary values of this deviation because for any data set it is 0. Therefore, what statistician has suggested is to get this summation at this deviation by ignoring the sign of the deviation. So we call that value, that is value ignoring the sign of a value, we called as the absolute value denoted using within two vertical lines. So absolute value of this deviation I can denote as like that. Here also same. This is absolute value. So if you add this absolute value, then you will get something, not 0. So now you have a summary of this deviation, and in order to find the average of this deviation, they have suggested to divide the quantity by number of observations. So mean absolute deviation can be found by first finding the deviation of each and every observation in the data set from their mean and finding absolute value of those deviation and getting summation of those absolute value of deviation and averaging that summation. So here I have a data set, observation 6, 9, likewise. Here, when calculate the mean and deviation, you can see this is the deviation of first observation from the mean. This is the deviation of second observation from the mean. When we add this deviation, value is 0. Value is 0. To overcome that, what we are doing is we are ignoring this sign. We ignoring minus here and ignoring plus here. Now, when we add, ignoring the sign, we will get the value. And when we divide it by number of observation, 10, we will get 7.3. That is the mean absolute deviation of this data set is 7.3. Here, not like in the range, each and every observation in the data set has contributed for this value. So we have some advantage and disadvantage of mean absolute deviation. That is, advantage is each and every observation contribute to construct the mean. It is easy to construct and easy to understand. And disadvantage is sign is not considered when we calculating this deviation. We don't know for which direction it is deviating. Next measure of dispersion is called as variance. In the mean absolute deviation, we get the contribution of all the data point for that measure, not like in the range. But they are, when constructing the mean absolute deviation, problem was summation of deviation getting 0. Summation of deviation getting 0. X bar getting 0. It was overcome by getting absolute value of this deviation. Another way to overcome this problem is to get the square sum instead of absolute value. Square, we have to first find this deviation, then square these deviations. When we square negative things, it become positive. Therefore, this sum becoming summation 0 is not happen. Therefore, another way to get rid of the overcome problem of getting the 0 is square the deviation and then get the summation. So if we get this deviation, then square and get the summation of those square deviation and divided this by number of observation, we call that quantity as variance. As you know, we have two source of data. Our data set can come from population or sample. If our data set is from entire population, the variance calculated from that data set we represent using sigma square, and formula used to calculate the population variance is summation xi minus x bar square divided by n. Here you know xi is any of the observation in the data set. Mu is the population mean, and n is the number of observation in the data set. So using this formula, you can calculate the population variance. If your data set comes from sample, that variance is denoted by S square. The formula is similar, except here divisor or denominator will be number of observation less 1 in the sample. If we have 10 observation in the sample, denominator is 9. That is 10 minus 1. This is because we know when the if the our from our population we can take many samples. These samples means vary, sample statistics get vary. And if we get the average of these computed sample statistics, it should be equal to population statistics. So if we computed the sample variance by dividing this quantity by n, it will not be equal to population variance when we get the average of all those sample variances. If we divided it by n minus 1, then that measure, average of that measure will be equal to this population variance. So we call sample variance is unbiased estimate of population variance when we calculate using this formula, unbiased. That means average of all the possible sample variances will be equal to population variance. If you use n here, it will not be equal to population variance. That is a biased estimate. So overcome that problem, statistician has suggested to divide sample variance. In sample variance, use device as n minus 1. Okay, we have given one example. We have a data set, daily sales of sugar in a certain grocery. Monday, 75 kilograms, Tuesday, 120 kilograms, likewise, Saturday, 140.5 kilograms. We need, you can see these data are not same. There is a variability. This is not like this one. There is a variability. We have to give what is the variability of this data set. If in every day that grocery has sold 75 kilograms, this data set don't have variability. Every day 75. So variability of this data set is 0. In real world, our variables are not like that. Those have variability. So we have to get a measure of that variability. So one measure that we use was range, then mean absolute deviation, then variance. Variance of this data set can be calculated. First, finding the mean of this data, then subtracting mean from each value and finding the deviation. These are the deviation. Mean was 78 kilograms, then 75 minus 78 is minus 3. Likewise, we have found deviation of each and every observation from the mean, xi minus x bar. Now, in the variance calculation, we have squared this deviation in order to become total becoming 0. In order to avoid the total becoming 0, we have squared. Now, I have squared this deviation and obtained the sum of those squared deviation. This is sum of squared deviation. We can write it as this as sum of what? I minus x bar deviation square of it. So we have to sum what? This sum of squared deviation. So that quantity is this much, and we have to divide, if this is this data corresponding to population, this quantity, this sums of square deviation by number of observations, 6, in order to find the variance. So variance is 1812.58 for this data set. You can see here we have measured this variable in kilograms. So this deviation also in kilograms. And when it is squared, what will happen? It will become kilogram square. Original measure is in kilogram. Now our variance is unit of measurement of this variance is kilogram square. Kilogram square. Because we have squared this deviation and get the summation and has taken the average of that. So unit of measurement of variance is kilogram square. It is somewhat odd. We need to represent that measure of variability using the same unit as we measured our variable. So we have suggested, statistician has suggested another measure of this variability we called as standard deviation. It is nothing but square root of variance. Square root of variance. So square root of variance we called as the standard deviation. So unit of measurement of variance, standard deviation is same as original measurement, kilogram. So standard deviation, as I explained, you can follow same steps to calculate the standard deviation. We are denoting population standard deviation using sigma. Sigma, we denoted population variance using sigma square and standard deviation using sigma. So population standard deviation can be calculated by getting square root of what? Variance. Variance is summation xi minus x bar square divided by n for the population. Similarly, if your data set come from a sample, then sample standard deviation is denoted by simple s. Simple s can be calculated using getting the square root of sample variance. Sample variance. So you can calculate the variance standard deviation of that data set of sugar sale using similar step. Here difference between variance and standard deviation is is the square root of variance. Square root of variance. You can get the square root of this value, that will be standard deviation. Unit of measurement is kilogram here. Here it was kilogram square. One disadvantage of this variance and standard deviation is we cannot use that to measure to compare the two populations, variability of two populations. I will give you an example here. We have two data set from elephant and from ants. Here we can see measurement from elephants are in kilograms corresponding to 1500, 1600, like weights are in thousands. Here in the ant population, the weights are in grams, 3 grams, 7 grams, 11 grams, 5 grams, 14 grams likewise. When we calculate the standard deviation of this population of elephant, sample of elephant, it is equal to 103 kilograms. The standard deviation of ant sample is 4.47 milligrams. So if we compare variability of these two population, you will say higher variability has occurred in the elephant sample or elephant population because it is 103.5 kilograms. Here, this is less because they are 4.47 milligrams. This is less. But when we focus on the data, you can see here this data point 7 is twice bigger than this data point 3. And even this 11 is almost 3 times of this observation. You can see here variability among observation is higher in the ant population. But in the elephant population, we don't find any observation that double the smallest data point. So compared to ant data, elephant data has less variability, less deviation among those data points. But here, large deviation. It is not represented by our measure, standard deviation or variance. Therefore, statistician has suggested another measure of variability that is called as coefficient of variation. Coefficient of variation can be used to compare variability of two different populations. Coefficient of variation we represent as CV. CV is calculated as standard deviation divided by sample mean and multiply by 100. And here unit of measurement in coefficient variation is percentage. We express this as a percentage. We calculate the coefficient of variation of elephant population. It is 6.3%. And ant population, it is 55.9%. Now you can see clearly ant population has higher variability in their weights compared to elephant population, elephant weights. So when you are describing spread or deviation of a data set, you have to describe your data set using several measures, not one measure, because one measure has certain advantage as well as certain disadvantage. If you are reading your research papers or any other publication, published statistics, census and statistics, or research papers, you can see they have reported many measures of central tendency and many measures of uh, this, uh, dispersion. Then that will provide more information rather than giving only one statistical measure. Okay, next aspect of describing data set is measure of relative standing. First measure, measure of central tendency. Second measure, measure of dispersion. Third measure is measure of relative standing. Here we describe location of data points in the data set relative to other values in the data set. Relative to other values in the data set, we give the relative position. This is sometimes important for decision making. For example, in the international exams like GRE, then TOEFL, then SAT, they are students are facing this exam from many countries, and by giving scores of obtained for particular exam, assume 70, sometimes this 70 may not much informative. We may need to know where this 70 is located. Sometimes this 70 may be the lowest data point in the data set. And this 70 may be highest data point in the data set. So if someone say, oh, my GRE score is 700, it will not give any meaning or much information to make a decision whether he has performed well or not in that exam. If we say, okay, I got the GRE exam and I am in 90th percentile, 90th percentile of my score, GRE score. That means 90% of students who took GRE in that exam has below this 700, and this student is in upper 10% of the GRE mark. So my score is in 90th percentile. My score is 99th percentile. That is, he is in the top 9 among the top 99 students. So this is the 90th percentile or 99th percentile is relative position of this data point relative to the other data points in the data set. So this relative standing is sometimes important in the decision making. Therefore, it is better to report when you summarize your data set also. When you calculating these relative standing measures, you have to arrange or order data set in ascending order. ascending order. First measure of relative standing is percentile. Percentile. Percentile divide ordered data set into 100 equal parts. Here, if we have minimum value of our data set and maximum value, what percentile is doing, it will divide this data set into 100 equal parts. That means first percentile. First percentile means 1% of the data in the data set are less than that value. And 99% of data in the data set are greater than this value. That is the first percentile. If it is 90th percentile, that means 90% of data in this data set is less than that value and 10% of data greater than that value. Likewise. So this we commonly call P percentile. P percentile, it may be first percentile, second percentile, third or 99th percentile. And location of P percentile can be found using this formula, that is n plus 1 divided by 100 into P. If here I want to find the 90th percentile, then assume there are 500 in the data set. I want to find the 90th percentile. So here n is 500, n plus 1 divided by 100 multiplied by 90. This will be the location of the 90th percentile. So 501 divided by 100 multiplied by 90. This will be the location of 90th percentile. Then after arranging this 500 data point in ascending order, you have to find the what is the value corresponding to this position. For example, here I have 8 data point in the data set. I want to find the 25th percentile. 25th percentile. So location of 25th percentile can be found by adding 1 to number of data point, that is 8 divided by 100 and multiply by required percentile. Here required percentile is 25th. Therefore, I have to multiply it by 25. So 8 plus 1 is 9 divided by 100 multiplied by 25 is 2.5. So my 25th percentile will be at here first location, second location, in between second and third location and towards the second location, because here it is 2.25. We have to go 2 unit here and further 0.25 unit from here to here. 25 unit. You can see when we are going 1 unit, that is second point to third point, it is changing to when we go 1 unit from second observation to third observation, the value getting changed by 2. So we want to find out what is the change when we go 0.25 unit from 1 to from 1 2 second observation. That will be when we go 1 unit, it will be 2 unit change. So when we go 0.25, there will be 1.5 change. For 1, there is a 2 change. So for 0.25, there will be 1.5 change. So 0.5 change. So 25th percentile will be 0.5 unit, 0.5 unit away from this second observation. So that value will be therefore 5.5. Second observation is 5. Another 0.5 we have to go. Another 0.25 we have to go in order to find the 25th percentile. That value will be 5.5. Next measure of relative standing is decile. Decile. Like percentile divided dataset into 100 equal parts, deciles. Deciles divide the dataset into 10 equal parts. This is the first part, this is the second part, likewise 10 equal parts. So this is the location of first decile where 10% of the data less than first decile and 90% of the data greater than first decile. So location of dth decile. Dth decile, D is 1, 2, 3, 4, 5, 6 or 10 can be found by adding 1 to number of observation and dividing it by 10 and multiplying by required decile. So fifth decile of this data point, fifth decile of this data set, I can find by dividing 9 by 10 and multiplying by 5. That is the location. So 10th decile, fifth decile will be located at 4.5th place. Here, first place, second place, third place, fourth place, and it will be at 4.5th place. 4.5th place. So here at fourth place we have 8, fifth place we have 9. So at 4.5th place we will have 8.5. So fifth decile for this data set is 8.5. Then next measure we called as the quartile. Quartiles divide data set into 4 equal parts. Here first part, second part, third part and fourth. So this is the first quartile, this is the second quartile, and this is the third quartile. So first quartile is that where 25% of the data less than that and 75% of the data greater than that. Similarly, second quartile is the value that 50% of the data less than that and 50% of the data greater than that. So you can see this second quartile is equal to median of a data set. So qth quartile of a data set can be find using this equation where n plus 1 divided by 4 multiplied by required quartile. So first quartile of this data set where we have 8 data point. So 8 plus 1 divided by 4 is 2.5 and we need first quartile. So we have to multiply by 1. So location of the first quartile is 2.2 fifth location. This is first location, this is the second location, this is the third location. So we have to go 0.25 from this second location in order to find the first quartile. So it will be 5.5 because here we have 5. When we go 1 unit, there 2 units will be changed. Then when we go 0.5 unit, there will be 0.5 unit change. 0.25, 0.5 unit. So 5.5 is the first quartile. Similarly, third quartile will be at 6.7 fifth location. Here, first location, second, third, fourth, fifth, sixth. Here it is 6 and 6.7 fifth location will be there. We have to go 0.75 from 6th location to find the third quartile. So here 6 to 7 there is a 2 unit change. So when we go 0.5 distance from 6 observation, we have to go 1.5 there. So value will be 11 plus 1.5, 12.5. We have another statistics called as IQR, interquartile range. This is not a measure of relative standing, it is a measure of spread of data set. IQR, interquartile range, is difference between third quartile and the first quartile. Third quartile and the first quartile. So in this above data set, third quartiles were 12.5, first quartile was 5.5, So interquartile range is 7. This is a measure of split. We had measure of several measure of split, range, mean absolute deviation, variance, standard deviation, coefficient of variation. Those were affected by extreme observation. But interquartile range IQR is not affected by extreme observation because here we are omitting these lower end data point and upper end data point. Here we have Q1, here we have Q3. It is the range between first quartile and third quartile. So extreme observations are not involved in this calculation. So to this measure, IQR, extreme observation will not be affected. Then another measure of dispersion is called as quartile deviation. This also described as measure of central tendency also. This also described as measure of central tendency as well as measure of dispersion. Quartile deviation is nothing but IQR, interquartile range, that is Q1 minus Q3 minus Q3 minus Q1 equal to IQR divided by 2 is the quartile deviation. Quartile deviation. So I have given one data set in the slide and calculated first quartile, second quartile, interquartile range as well. So you can practice this and get familiar with these measures.